Right, we're carrying on with this electrolysis. So remember this is what we said. Sodium chloride is in solution. What they mean is aqueous. So straight away we know we've got, let me write this, sodium chloride. So this is how you should be thinking. And you've got water. But we said water splits up into hydrogen ion and hydroxide ion. Right, so I'm going to get rid of that. I'm going to now get the Jua. I'm going to move that there. I'm going to move that to that side because it's going to flow over there, and that's going to flow over here. Because they go to the opposite electrodes. Right? This is what we also said. We said electrons carry the charge in the outside circuit, electrons, and ions carry the charge in the solution or the electrolyte. Right now, first question, draw an arrow on the diagram, show direction of electron flow. So electrons are flowing this way. Okay. It goes from negative all the way around back to the positive. Right, the diagram shows one of these gases being collected at Q here. Right, so let's talk our way through this. Let me get rid of that. Get rid of that. Let me get rid of that. Just close up the thing. Right. So what we've got is this. We've got hydrogen ion, sodium ion. We know the hydrogen ion is more reactive. No, sodium ion is more reactive than the hydrogen ion. So remember, said, please. So your teacher complains and says, please stop losing careless marks always. And then we said chicken, didn't we? And then the zoo is, and then you've got your three metals: copper, silver, gold. These are all in the periodic table, one after the other. So if you can remember copper, the other two will fall in. This is zinc, this is iron. Right, we said these two are non-metals, they're just reference points, so that's carbon, and that is hydrogen. We carry on. Aluminium, magnesium, calcium, lithium, sodium, potassium. Right, nice. Right, so what happens is this is more reactive, it wants to stay like that. So what happens, hydrogen goes over, collects an electron, and becomes a hydrogen atom. Another one of them goes over, collects an electron, and becomes another hydrogen atom. So these two hydrogen atoms join together to form hydrogen gas, and then it floats off. So that's hydrogen gas. Why 2? Because it's, what's the word we said? It is a diatomic molecule. So what would it, remember what we said? No. And then you've got your halogens. So fluorine, chlorine, bromine, and iodine. We're not interested in astatine. If you can learn these as diatomic, it's going to be very useful. And learn that. Right, let's jump across here. Right, hydroxide is slightly less reactive. No, slightly less reactive than chlorine, only slightly. But because there's that many more chlorine or chloride ions, what happens is the chloride ion loses an electron, becomes a chlorine atom. Another one loses another electron, becomes another chlorine atom. They join together to form a diatomic molecule, and then the flow offers gas. So that there will be chlorine. So Q will be hydrogen. Ooh, now we've got to do this. When concentrated sodium solution is low, the gas collected is mostly oxygen. Yes. So again, it's good to know. This is a really good question to keep hold or learn. So as the concentration becomes of sodium is low concentration, you're going to start getting oxygen forming. So you've got your hydroxide ion. Let me get this right. So your hydroxide ion gives water, slightly a bit cocky, that's O2, oxygen, and then you've got electrons. So let's balance this out. You've got 2 hydrogens, 3 oxygens. 2 hydrogens, 3 oxygens. So if we put 2 there, we've got 4 hydrogens and 4 oxygens. So if we put 4 there, we've got, on this side, we've got 4 oxygens, 4 hydrogens, and we've got 4 extra electrons. Can you see this minus here? Yeah, so let me just rub everything out just to make it less sort of chaotic. Right, on this side, you've got 4 hydrogens, you've got from there to there 2 plus 2 is 4 oxygens, and we've only got 1 electron at the moment, so we put 4 there. So now the charge is balanced as well. There you go. Right, when the concentration is high, what happens? I don't know. Let's have a look. Right. They normally give you that. They'll either put, look, 24,000 centimeter cubed or 24 decimeter cubed. They're the same thing. So look, you need to know 1 decimeter cubed, especially if you're doing the higher, right? Paper 2, but you're not. If you're not doing paper 2, don't worry about it. I mean, that's why you're watching this. To be honest with you, it's 1,000 centimeter cubed. There you go. Done. End of story. What's next? So when the concentration of sodium chloride is high, the gas collects in the test tube is mainly chlorine. The equation for this is like, can you see you've got 2 chloride ions gives 1 chlorine molecule and 2 electrons, because 2 times -1 on that side, 2 times -1 on that side, it balances out. So this is how I like to picture it, otherwise I get lost. I like to see here, I've got a container that is 1 decimeter cubed. 1 decimeter cubed, right? And it will contain 1 mole of gas, whatever gas it is. Now, if I only I'm such, I need to stop lying. Got my habit of lying. Let me go back. Right. For 1 mole of gas, we need 24 of them decimeter cubed, and they give you that here. But they've given you in centimeter cubed, so I can say 1 mole is equal to 24,000 centimeter cubed. There you go. Right, what's next? Right, but they only made 18 centimeter cubed. So they only made a fraction of it. So they made 18 out of 24,000, and then you multiply that by, well, okay, that's it. Well, 1, because that's the molar concentration really as such. What will it be? Right, the answer would be 0.00075 moles. Right, I hope that helps, because what I try to do is I try to turn it into a fraction. It's the volume over molar volume times 1. In this case, that's the concentration. Right, that's the answer. So the answer is 0.00075. You can write it as 7.5 times 10 to the minus 4. Right, okay, this is no longer in the spec. We don't need to do it. Right, so 1 Faraday is that. So 1 Faraday. So what we do is we do 96,000 coulombs times the number, which is 0.00075. And because chlorine is diatomic, we multiply it by 2. Right, we're not worried about that. Right, we're interested in now chlorine reacts with potassium bromide. So remember, for group 7, fluorine, chlorine, bromine, and iodine, astatine, right? Reactivity goes down. It decreases. So when they add chlorine to potassium bromide, chlorine can kick out, is stronger than bromine. That's why you get a displacement reaction. So what happens is bromine is kicked out and chlorine goes in its place. Identify the element that is displaced. So this can be described as a displacement or redox reaction. Which element has been displaced? It's the bromine. The bromine has been kicked out from its position. Whoa. Bromine. Yeah. What does the word redox mean? Simple. You've got to learn this when it says when reduction and oxidation occurs at the same time. There you go. Right, we can finish this off here. Yeah. Right, the chlorine manufacture of phosphorus pentachloride. The equation for the reaction is this is equilibrium. Right, okay, listen, forget this. This has been covered in something else, but listen, it's always good to know this anyway. Look, that's a typo. This means that this reaction means that the forward and backwards or reverse reaction occurs at the same time. Or you can say something like this: the reaction is reversible. The reaction is reversible. Predict and explain the effect of increasing pressure on the equilibrium position of this reaction. If you increase the pressure, so look, you've got 1 mole or 1 mole, and you've got 1 mole. So this is the high pressure side. This is the low pressure side. I'm just quickly going through this. What will happen to the equilibrium? If you increase it, the system will go to the low pressure side. The equilibrium will shift to the right. The equilibrium will shift to right. Why? Because there is less molecules or moles, use molecules, on the right hand side. I'm just being lazy with this. This is not for this. I'll tell you what, right, we'll call it quits there. Shall we call it quits? Yes, we shall call it quits. No, we won't call liquids. What we'll do is we'll try to squeeze this on this video. Right. This table shows some results of electrolysis of aqueous. Right. Solutions using inert. Inert just means unreactive, not reactive. Right. You've got copper sulfate. At the negative electrode, you end up with copper because copper is a positive ion. At the positive electrode, you end up with oxygen. In the solution, you end up with sulfuric acid because you've got sulfate. Right, potassium. At the negative electrode, you've got hydrogen. And not potassium because potassium is more reactive. Silver, oxygen, nitric acid. Right, silver, sulfate. So you'll get silver because silver is very unreactive, so it'll try to get back into its silver state, into its original state as an element. Potassium nitrate, you get hydrogen, you're going to get oxygen because it's aqueous, oxygen. So hydrogen's gone, so you're going to end up with potassium nitrate, same thing. Potassium nitrate. Right, so let's try, should we try to draw that? No, we won't, we'll leave it like that. Let's move on. Right, you need to use electrodes that are inert, unreactive. Carbon is one of them, and platinum, just learn them to suggest a suitable element for inert electrodes. Yeah, any one of those two, carbon or platinum. Suggest why a small amount of dilute acid is added to the water before it is electrolyzed. To increase its electrical conductivity, because pure water does not conduct electricity. So to increase its electrical conductivity. Okay. So the overall equation for the decomposition, when something decomposes, it breaks down. So water has broken down into hydrogen and oxygen. Use this equation to explain why the volume of hydrogen should be twice the volume of oxygen. So if you look here, there's 2 moles of oxygen for every 1 mole of 2 moles of hydrogen for every 1 mole of oxygen. I need to get that right. I'm half asleep at the moment. So that's what you can write down. So hydrogen produces 2 moles of gas. Whilst oxygen produces 1 mole of gas. Okay. The volume of oxygen is always slightly less, even though there are no leaks. right, you can put down some of the oxygen dissolves in the solution. Some oxygen dissolves in the solution or in the water. That's it. Right. Okay, let's get this finished on here. No, this is an electricity question. So calculate the number of moles. So we use that many coulombs. 1 Faraday is that many coulombs. So how many Faradays have we got? We've got 82500 divided by 96500. It's just like a math sort of question. So we've got 5 Faradays worth of electricity. Right. Calculate the number of hydrogen. Okay, because hydrogen is diatomic, we do 5 divided by 2. With 2.5 moles of hydrogen. Okay, that was not really needed. Okay, now we're going to do this question but on the next video. Right, okay.